All right, geometry students, I'm going to walk through a few of the concepts from Unit 9 that are not covered on the Khan Academy videos. So we're going to be talking about ratios and proportions in this lesson. So I'm going to talk through some of the vocabulary and how to solve proportions. So the first thing that you need to know is what a ratio is. So a ratio is really just a fraction. It's a comparison between two numbers. So a fraction is, like for instance, the fraction 2/3. We're saying that there is 2 parts out of the whole of 3. So there's 3 parts, and we have 2 out of the 3 parts that make up the whole thing. And that's what a ratio is telling us. Okay, ratios can also be written other ways. You can see them written just like a fraction. They can also be written as, actually erase that. It can also be written like this with a colon here, 2 to 3. Or they can be written in words, 2 to 3. Okay, so 2/3, 2 to 3, or written out all the way 2 to 3. So these are all examples of ratios, and it's a comparison between two numbers. So in geometry, we look at shapes and we can make comparisons based on their sizes. So imagine we have these two, and I'm going to actually make this one look a little bit more like I want it to. Yeah, like that. Okay, so this would be a shape, and let's say that the length of this side is 4 and the length of this side is 6, and this one is 8. So this would maybe be 12, 8, and 16. And so we can see that this shape, everything in it is twice as much as this other shape. So the ratio between these two shapes would be 1 to 2, because for every 1 over here, there's 2 over here. So this is how ratios are used in geometry. And we'll talk more about how we solve problems dealing with this. And you'll notice the connection between this and the stuff you're doing on Khan Academy, especially when you do dilations. All right, so I'm going to erase this. And we'll talk about proportions. So a proportion is 2 ratios that are equal to each other. So like 2/3 could be equal to, for instance, 6 over 9, because the relationship between 2 and 3 and 6 and 9 are equal to one another. And I don't really think I need to explain that whole understanding of how that is, but you know that 2 times 3 is 6 and 3 times 3 is 9, so these are in the same proportion to one another. Now, when we do this, what we're really going to be looking at when we do problems like this is we're going to be looking at one of these things being missing. But before we get there, we need to talk about some of the properties we have within this proportion. So within this proportion, we have 2 different sets of numbers. We have, if we were to number these, it would be like spot 1, spot 2, spot 3, and spot 4. So we have these 4 spots. And the thing we know is that the thing in the first and last spot, we call those the extremes. I'm going to write that down, extremes. And the things in the other 2 spots, the middle 2 spots, are called the means. So we have the means, these 2, and we have the extremes, these 2. And so there is a property that exists between the means and the extremes. And that is, if I multiply the means, 3 times 6, write that down here, 3 times 6, and I say multiply the extremes, which is 2 times 9, they are always equal to one another. So 3 times 6 is 18, 2 times 9 is 18, and so you see the means and the extremes are equal to each other. That's true for all numbers that are in proportion. So let's say I don't know everything in my proportion. So I have a proportion, and it is 4/7 is equal to x over 21. It's like, okay, I don't know what this is. I know that the relationship between those numbers is 4 over 7, or the same as 4 over 7. And so how can I solve this? Well, we're going to use the property we just talked about, the means extremes multiplication, which is also known as cross multiplication. And I ran out of the room writing that. Cross multiplication. You guys have heard of this before. So we're going to multiply these numbers, 7 times x, and we know it's equal to these numbers multiplied, 4 times 21. So 4 times 21 is 84. And so then I have 7x equals 84. So I'll divide by 7 on both sides. And when I do that, this cancels out, leaving me with x equals 84 divided by 7, which is 12. And so then I know that x up here is equal to 12. So 4 over 7 is equal to 12 over 21. So this is how cross multiplication works when you're solving for one of these missing numbers. So let's do one more example. So let's say I have the fraction 2/5 equals 8 over x. So notice I move the x to a different location. It's not in the top, but it doesn't matter. The same process is going to apply. I'm going to multiply these two numbers. 2 times x is 2x. Multiply these numbers. 5 times 8 is 40. Then I'm going to divide by 2 on both sides. And x equals 40 divided by 2, which is 20. So this is all cross multiplying is going to be. It's going to be you taking the numbers, multiplying the diagonal numbers, and then dividing to solve for x, doing that basic algebra there. So this is basic proportions. This is kind of everything you need to know for some of these problems. And I'll be posting a few different worksheets for you to practice, but this is one of the basic skills that you're going to need to know. And the next video, I'll talk about how this applies to geometric shapes.